In this episode, I wanted to introduce you to Puppet. Puppet allows you to quickly automate many sysadmin tasks, like deploying new machines, pushing configuration changes out, and it also helps you verify the configuration on existing machines. Puppet is essentially a piece of software called an agent that runs on each of your machines. This agent talks to a central server called a Puppet Master. You can also run these agents in a standalone mode, without the need for a Puppet Master like we're going to do today. The standalone mode is not only useful for learning Puppet, but it's also great for testing scripts before you deploy them to your Puppet Master. But I'm getting ahead of myself. Rather than telling you all about Puppet, let me just show you. This might not make sense at first, but bear with me, it'll all come together. I've put together some example Puppet scripts, which are typically called manifests. The first file we are going to look at is something called a node definition. The node definition defines which Puppet scripts or manifests are assigned to a particular node via these include lines. In this node definition file, you'll define all your servers, something like this. Then you'll assign Puppet manifests to each node. So let's say you wanted to configure HTTPD and MySQL. Under the node definition for that particular server, you'll just include your Puppet manifests like this. Or maybe you have multiple servers and you want to do some load balancing. You could do something like this. Now we're going to define server 1 and 2 as HTTPD instances, and server 3 as a MySQL server. This is just an example. I just wanted to show you the power of these include files. So via these Puppet manifests and the node definition, we can deploy changes to any number of servers without actually having to log into any of them. These manifests are also self-documenting, in that if you use Puppet to build servers from scratch, then you'll have a clear picture of what your infrastructure looks like just by reviewing the node definition. Okay, now that we know what the node definition is all about, let's take a look at these manifest files. A manifest can be something as simple as creating a file, tweaking a permission, or range to very complex multi-platform behemoths. As you can see here, we include a MOTD manifest, which modifies the message of the day. Let's go ahead and take a look at how this script works. You can see the directory structure over on the left. Under the module subdirectory, there is a directory called MOTD. And in here, you'll see two directories, one called files and the other manifests. Let's take a look into the manifest directory and you'll see a file called init.pp. In this init file, you'll see that I've defined a MOTD class. This is what a very simple Puppet manifest will look like, and it uses the programming language and syntax of Ruby. Don't be scared if you don't know Ruby. Actually, before we look at this Puppet manifest, let's take a look at a website that's been immensely helpful in helping me learn Puppet and a bit of Ruby syntax too. The site is called Puppetcookbook.com. And it has simple, straightforward examples that will help you get your foot in the door. Armed with the Puppet Cookbook, you'll have Puppet installing packages, creating directories, and deploying changes in no time. Okay, let's head back to our editor and take a look at the MOTD class. Here we define a file, /etc/MOTD. We make sure the file exists, set some permissions, and set the file contents by pointing it to a source file. This can be extremely helpful for deploying configuration files. Let's take a look at the file contents that we're going to deploy by navigating over to the MOTD module, and we're going to look into the files subdirectory. As you can see, there's a file called MOTD, or message of the day. Here you can see my nice little message of the day message. On machines that I manage with Puppet, I like to throw in a little line in the message of the day giving everyone a heads up that this machine is managed via Puppet, just in case someone tries to manually make a change to the machine and it gets reverted. You see, Puppet not only deploys changes, but it makes sure changes persist. What I mean by this is that Puppet will, by default, run every 30 minutes and check your Puppet manifests, and it verifies all the changes. So for example, say we manage /etc MOTD via Puppet. Then someone logs in and modifies /etc MOTD manually. On the next Puppet run, Puppet will notice that this file has changed by its checksum and change it back. This can be extremely powerful for verifying the state of your infrastructure, especially if you have tens, hundreds, or even thousands of machines. Just to review, let's flip back to the message of the day example. Here we define a file, make sure it has the correct ownership and file permissions, along with the contents. On each Puppet run, this file will be checked, and if it does not meet these requirements, it will be changed so that they are. Now that we know a little bit more about Puppet, let's flip back to the node definition. In the node definition, there's a manifest called OpenSSH. This example is a little more complex, but extremely powerful. Let's have a look. Again, on the left-hand side, we'll navigate down to the modules and open SSH. We'll open up the init file and have a look. In here, you'll see a very common pattern. It's typically referred to as the package, file, service pattern. First, we define the OpenSSH class. This uses Ruby syntax. Then we make sure the OpenSSH server package is installed. We define a config file. Then we make sure SSHD is running. Let's go over this example in a little more detail. Puppet acts as an abstraction layer above your operating system. So we say make sure OpenSSH server is installed. But how does it actually do that, you might wonder? Well, Puppet knows certain facts about your operating system. Like, for example, that this is a Red Hat Enterprise Linux machine, and so it should use yum to install the package. But this mechanism works across a variety of operating systems. Puppet's very clever like that. In this next block, we define a file, just like we did in the message of the day example. Then the next block here, we ensure that the service is running. This can be very handy in that you can define a bunch of manifests for each server and remotely control your infrastructure. Before we move on, I just wanted to show you one more thing. You can define relationships in Puppet. In the top block, you can see here that we have a before option set, and it points to a file. What this does is it tells Puppet that this package should be installed before this file is deployed. Say, for example, if we didn't do this, our file could be deployed and possibly overwritten when the package is installed. This just adds some assurance that the package will be installed before our configuration file is deployed. In this last block, we've defined a second relationship. You can see that we have the subscribe option set, and this also points to a file. What this does, and it's pretty cool, it tells Puppet that if this file changes, restart SSHD. So for example, say we tweak a setting in SSHD config. Puppet will notice, based on its checksum, and from this subscribe option, will automatically restart SSHD for us. Pretty cool. I should mention that there are tons of great examples on GitHub. And Puppet even has a community-driven repository of modules called Puppet Forge. See the links in the episode notes below. There are already tons of Puppet manifests for just about anything that you can think of, so it makes deploying scripts fairly easy. Now that we know a little bit about Puppet and how it works, let's see it in action. Let's look at setting up a development environment for testing and playing around with Puppet. We're going to use our newly gained Vagrant knowledge from episode number 4. If you haven't watched episode number 4, you should do that. Since this demo takes for granted some key Vagrant concepts, and it'll help you replicate my results. I've put together a CentOS 6.4 minimal Vagrant box with Puppet installed. We're going to use this Vagrant box to play around with Puppet and test our Puppet scripts. You can download the Vagrant box along with all the supporting files via the episode notes below. It's about a 375 meg compressed file. You'll need to have Ruby, VirtualBox, and Vagrant installed before you can use this Vagrant box. Alright, just download the package with wget or curl, like so, then unpack it and cd to the directory. In here you'll find the Vagrant box, some example Puppet scripts that we previewed earlier in this episode, a README file, and our Vagrant file. I also threw in the VW scripts used to create this CentOS box, just in case you're interested in seeing how they work. The Vagrant file is a little bit special in that I've trimmed it down and also enabled Puppet provisioning. This line tells Vagrant what box to use, and then here is our Puppet provisioning block, which essentially tells Vagrant to execute Puppet along with some settings right after the VM has started. Here we have the node definition, which we covered earlier, and the supporting modules and manifest directories. Now that you've seen the Vagrant file, let's add the CentOS box. We do this by running vagrant box add the box name, in this instance CentOS 64 64-bit minimal, and then we provide the box file, CentOS 64 64-bit minimal.box. Now let's fire it up via running vagrant up. Vagrant's going to boot our CentOS Vagrant box and then run Puppet. Let me just give you an overview of what is happening. Let's scroll up a bit to where we executed Vagrant up. This block here is standard Vagrant output, telling us about networking, port forwarding, booting the VM, and then mounting /Vagrant in our current directory. These next couple lines are additional mounts related to the Puppet config. Then our Puppet provisioning starts. As you can see, Puppet is running our node definition here. The rest of the output is generated by the example Puppet scripts which I've put together. You do not need to understand all the output, but I'll touch on a couple things. It looks like the message of the day was updated, and something to do with SE Linux, along with our OpenSSH tweaks. Then we're notified about the finished Puppet catalog run. Pretty cool. Let's log in and take a look around. We connect by running Vagrant SSH. Sweet, we're greeted with our custom message of the day, which was deployed with Puppet, by the way. Let's take a quick look at the Red Hat release file, and then run df to see what mounts this system has. You can see our /Vagrant mount. Let's take a look in there. You can see that this /Vagrant mount is our CentOS project directory that we downloaded earlier. I just love this feature because it allows you to share files quickly between your host machine and your Vagrant box. Okay, now let's take a look at our Puppet node definition file that we used to create this machine. I've included some example commands here that you can use to run Puppet manually. So if you make any changes to the Puppet manifests, then you can run this command and apply the changes. You can also run Puppet with the no-op option. This means that Puppet will run but not make any changes. This is handy for getting an idea of what might change. The reason why I love Puppet and Vagrant together is that you can test clean Puppet deployments. Let's walk through what I mean by this. First, we're going to log out. Then we're going to run Vagrant destroy. This is going to delete this instance of our Vagrant box. Then we're going to run Vagrant up again. You can see that we created a whole new Vagrant box, and our Puppet scripts were executed again. What's so great about this is that we didn't reuse our previous instance of a Vagrant box. This is a completely new one. So you have free reign to test destructive changes with Puppet. You could totally screw up the entire OS. Then you can quickly create a clean environment again. Anyways, I've probably been talking long enough. There is a bit of a learning curve with Puppet, but hopefully after watching this demo, you'll see that it's well worth it. Before I conclude this episode, I just wanted to remind you to check out Puppetcookbook.com. Hopefully you're comfortable with Puppet and Vagrant enough that you can continue on your own. Alright, that concludes this episode. Thanks for watching. If you would like to get notified about future episodes, please subscribe to my mailing list. You can do this by going to the Get Notified link in the header and entering your email address. Have questions, comments, or concerns about this episode? What about episode ideas? I'd love to hear your feedback, either good or bad. Shoot me an email, justin@sysadmincasts.com.